Hello, welcome to a video for intermediate algebra. Sorry about that. Just going to review some stuff from week 1 and take a look at the first quiz for this course. So, I believe everybody has read through the introductory material, the welcome message, printed out your daily work schedule, taking the syllabus quiz, intro to my open math assignment, taking a look at math utilities. You need some kind of graphing utility for this class. I'll show one in the next video. Optional, anything that's optional is optional. You don't have to do it, but some good stuff there. Where the materials came from, other of my YouTube videos, and then the testing. So first, the daily work schedule. So that page shows what I expect you to work on each day. And you should notice, as I mentioned before in a video and a message, that it is slightly different than the Canvas calendar. Why is that? Well, these are the days I expect you to do stuff. So for example, I expect you to finish section 1-2 yesterday so that you can be working on 1-3 today. Now, shit happens in life, and so to deal with that, I give you an extra day for the deadline. If you wait to do things in the deadline, sometimes you can't get them done in one day, then you're perpetually a day or more behind. And that's not a good thing in a college course. So these are deadlines. This is the actual work you should be doing each day. So post this somewhere prominent so you look at it every day, make sure you're on track with the course. Okay? If more happens in your life than just that one day extra I give in the Canvas calendar, then you can apply late passes for yourself. So if you haven't already figured that out, let's take a look at homework 1-2. Let's suppose you didn't get that done yesterday and you don't think you're going to get it today. Ruh-roh. Gotta sign in. Let's see. Apparently I haven't gone in here with my test student. Okay, so there'll be an option to redeem a late pass. So if you don't think you're going to get it done in the time that's left, then give yourself that late pass. Okay. And now you have 48 hours more than the initial due date. So the initial due date for this was the 6th today. I now have until the 8th to get it done. So each late pass gives you 48 hours. You have up until the day after an assignment's due to apply a late pass. You can apply it anytime before. If you, 3 days later, you realize you didn't do something and you want me to apply a late pass for you, then it's going to cost you more. Each late pass is only worth 24 hours. So if it's 3 days after the due date and you need one more day to get it done, that means it's going to cost you 4 late passes. You only have 20 for the quarter. You have about 30 assignments. So use your late passes wisely. Pay attention to the daily work schedule. Canvas stuff are deadlines. That's a day after I expect you to get it done. So keep that in mind. Testing. This class does have some tests. There are 2 midterm exams, exam 1 on chapters 1 and 2, exam 2 on chapters 3 and 4. Calculators are allowed on those 2. Then the final exam is in 2 parts, the exit and the rest of the final exam. No calculators on the part I call the exit. Calculator can be used on the second part. These exams are online like your homework, except they're password protected. So you have to go to a proctor to take them. So either a testing center or you have to set up a proctor in some other way. See details below on this page. And very important, all work must be written on paper, neat and numbered, and submitted to me or your proctor. So if you take it at a testing center, they know to get it to me. You should remind them. If you do it with ProctorU, it's your responsibility to send it to me the day you take the test. This is super important. When you do your homework, you should write your work down. So here's some examples of written work for a problem you might see in chapter 1. First one right here is bad written work. Here's the problem. The student scribbled down a couple of things. Maybe those are the answers 2 and 3 there. It's not clear. Now you're going to type something in the little box in my open math in the homework part. So I'll definitely see an answer there. But if I look at your answer and it's wrong, and I look at this and this is your work, this isn't good. I can't tell anything from this. The problem is just wrong. Over here is an example of good written work. You know that this number over here, its factors determine how the middle term is built. And so you break it apart and try and figure out how to build that middle term. Once you find the proper pair, then you can break it down into factors. I'll do some examples of this in detail in a moment. And then you can use what we call the zero product rule to break it into two different problems and find two possible answers. And then you ought to check. Anytime you solve a problem with algebra, it is an educated guess. You don't know if it really works until you check. So I checked. I found that plugging in 6 on the left side gave me the 0 on the right. I found that plugging -1 in on the left side gave me 0 on the right. Okay, good work. So every time you do a homework problem, you should be writing down stuff like this. If you're not, then the test ain't going to go so well for you. Super important. Please do that. If you have any questions, let me know, but you should keep a detailed homework notebook where you label each section or chapter you're in and label the problem number, write down the problem, and do the work. If you're not doing that, then things may not go so well in the future. So please have good study habits. Very important for a class like this. Let's see, anything else we need to look at? Testing. All right, so back here to the home page. Reminder about the way this course works again. I'll continue to post new quizzes pretty much each week in the surprise quizzes section. If you are tired of looking at this introductory stuff here, you can always hit that little arrow there to minimize it, and you can always maximize it if you need to look back at, say, the testing policy or the daily work schedule or a link to the main textbook. Otherwise, each day you're going to do some reading, you're going to watch some videos, and you're going to do some homework. Right? Sometimes I add extra links, like in chapter 4, I add a page called what's called the general factoring strategy, which is basically a summary of the entire chapter on 2 pages. So I list all of the steps that were covered in all 3 of those sections, and then I give some examples of me working through those steps there. So this is a good thing to take a look at, print out, give it a shot. All right, let's do some math. So you have a quiz, and your quiz has problems that look kind of like this one right here. So this is similar. Let me shift this up, give me a little room, to a problem on your quiz. Slightly different numbers. So I need to factor this. So there's a couple of different strategies for factoring. I'm going to demonstrate factor by guessing first, and then I'm going to do factor by grouping, or the AC method, second. So to factor this by guessing, I look at the first term and notice that is a 1y squared, and this is a 10, so only the 10 matters here. And 10 factors as 1 times 10, or 2 times 5. Now, since the 10 is positive here, that means I have to add these to get the middle term. And fortunately, 2 plus 5, oops, I need to change color. 2 plus 5 is 7. So since the factors give me 10 and the sum gives me 7, those must be the magic numbers that help me to factor this. So I believe, I'm guessing based on this work right here, that the factored form of that is equal to y plus 2, because that's a positive 2, parentheses, times y plus 5, because that's a positive 5. So I would circle that, believing that's my answer. It's equal to what I started with. So the instructions here would be something like factor completely. To check that I factored it completely, I'm going to do a couple of things. Completely. Spelling's never been my strong suit. First, I just want to look at the y plus 2 and ask myself, is there anything common to the y and the 2 as a factor? And the answer is no. If that was something like a 2y plus 2, then I'd say, oh, there's a common factor of 2. Right? So example of something more to do, if one of the factors was 2y plus 2, these guys have a common factor of 2, and I could take it one step farther, 2 times y plus 1. Okay, but that's not the case here, so I don't have to worry about it. But I should always double check that each new factor I come up with is factored completely. Same with the y plus 5. Y and 5 have nothing in common. All right, so next part of my check is to actually multiply that out to see if it equals what I started with. So I'm going to take that y plus 2 times the y plus 5 and pray. Y times y is y squared. Y times 5 is positive 5y. Positive 2 times y is plus 2 times y. And 2 times 5 is 10. And there happen to be like terms in the middle here, so I can combine those. So I'm going to get a y squared plus 7y plus 10. And that does match what I started with, so it is right. I have confirmed that this is the factored form. Okay? So this is what a complete set of good work looks like for this problem. If you're writing less than that, then your quiz grade ain't going to be so good. So write everything down. Another thing about writing stuff down is when you take a test, the more you write down on paper frees your brain to think about the problem as a whole. If you try to do too much in your head under the pressure that you're on in a test, that can end up being detrimental. So write stuff down. Practice on your homework so that on the test it goes well. All right, second problem on the quiz looks something like this, slightly different set of numbers. Looking at this again, that is a 1x squared. So the negative 35 is what's important to me. I'm going to write down negative 35. Now, I need to factor 35. What the negative means here is that I want to subtract the factors. Once I make a note of that, I really don't care about the negative anymore. So that's 1 times 35. Let's see, 5 goes into that 7 times, and that's all I got. Let's see, can I subtract these and get a negative 2? How about 5 minus 7 equals negative 2? Yep, that's the one I want. And it's worth writing this down to make sure you get that sign right there. Okay, so that's the magic pair. And by the way, I do what's called factor by guessing every time there's a 1x squared or a 1y squared. I'll show you the next method in just a moment. So I'm guessing this factors as a pair of binomials. X squared comes from x times x. Negative 35, I believe, comes from 5 times negative 7. So plus 5 minus 7. So I think this is equal to what I started with. So I'm going to circle it, believing it's my answer. Answer. Now to check a couple of things. Is x plus 5 factored completely? Yeah, x and 5 have nothing in common. X and 7 have nothing in common. So my check is going to be to multiply that out. So let's see. X times x is x squared. X times negative 7 is negative 7x. 5 times x is plus 5x. And 5 times negative 7 is negative 35. Now, I skipped rewriting this. That's not necessarily a good thing. I probably should have done that. So backing up to double check I did it right. Rewriting what I think the answer is. And the main reason I'm rewriting it is because distributing is a challenging piece of work. Sometimes it's nice to draw lines to make sure you got each piece. X times x is x squared. X times 7 is negative 7 is negative 7x. Double check the sign. Done distributing the x, now I distribute the 5. 5 times x is 5x. 5 times negative 7 is negative 35. Looking good. Any like terms? Yep, right in the middle. Negative 7x plus 5x, I think that's a negative 2x, a negative 35, and an x squared. Now, some of you might be tempted to just look at this and think in your head that it works. Often we deceive ourselves in situations like that. It's wishful thinking. Write it down to be sure. Don't look at the original problem while you're checking. And then after you're done checking, then go say, okay, do I have the coefficients right? Do I have the signs right? Okay, good. I got it. And then maybe recircle it to confirm to yourself. Ta-da. All right, let's try another. Now here, this one has a 3x squared, so I'm not going to do factor by guessing on this because I'm probably going to get it wrong the first couple of times. Here, what I'm going to use is called the AC method, sometimes called the factor by grouping. It's called the AC method because quadratic equations in general are written down as A some number times x squared plus B some number times x plus some third number. So this is a quadratic equation, and A is the first coefficient, and C is the last coefficient here. And what the AC method tells me to do is to multiply the first and last coefficient together. So positive 3 times positive 8 is what? Positive 24. Right? So that's my AC. That's 24. Now, since the 24 is a positive number, that means I add the factors to get the middle term. The previous problem, my AC was a negative number, and so that means I subtract those factors to get the middle term. So very important to consider those signs. It helps minimize the guesswork. All right, so let's stick with red. Pairs of factors. 1 times 24, 2 times 12, 3 times 8, 4 times 6, and sometimes a calculator is helpful to do this. On the exit exam, you can't use a calculator, which means you might have to do a little long division off to the side if you can't remember that. But usually I keep the numbers pretty small on the exit exam. All right, so another thing to consider is the sign of the middle term. Since it's negative, each of these numbers need to be negative. So a negative times a negative is a positive. A negative times a negative is a positive. Negative times a negative is a positive. Negative times a negative is a positive. So which pair of these added up to negative 10? And it looks like it's the minus 4 plus the minus 6. Oops, extra digit. And minus 4 plus minus 6 is negative 10. So that looks good. So this is my magic pair of numbers. So the next trick to do is in the AC method. So this was step 1 in the AC method. Step 2 is to rewrite the middle term. So first I recopy the other terms, 3x squared, leave a little space, and then plus 8. This work over here tells me that the negative 10x came from a negative 6x plus a negative 4x. So now I rewrite that in the middle. So now I'm going to have a negative 4x minus a 6x. Okay, so I still have that 3x squared out front. I still have the 8 out back. And would you agree that negative 4x minus 6x is negative 10x? Okay, me too. All right, so that's step 2 of the AC method. Step 3 of the AC method is what we call factor by grouping. So that's where I look at the first pair and I say, okay, what do they have in common? Well, they have an x in common. So I'm going to pull the x out. And what's left behind when I factor the x out? Well, factoring is like dividing. X goes into 3x squared, leaving a 3x. And x goes into negative 4x, leaving a negative 4. So that's the remaining factor. And I move over to the next part. Say blue. What can I factor from the second pair? Since it leads off with a negative sign, I'm going to have to factor a negative number. Otherwise, these guys have in common a 2. And then I see what's left behind. Now this is where it gets a little tricky. It's negative 2 I factored out. So negative 2 goes into negative 6x, positive 3x times. Negative 2 goes into positive 8 how many times? That would be a negative 4 times. Now what I want to have for step 4 here is I want these guys to match. And they do match. That's a success. If they didn't match, either I have an error here, or it's not factorable. Some things aren't factorable. All right, so just double checking that they match. If I take the x and multiply it back through, I get 3x squared minus 4x. Yup. If I take the negative 2 and multiply it back through, negative 2 times positive 3x is negative 6x. Negative 2 times negative 4 is positive 8. Yeah, that looks good. So yeah, I think they do indeed match. So once you find that match, you pull it out. So I pull out my 3x minus 4. And then I make a note of what's left behind because I pulled that out. Well, what's left behind is the x minus 2. That's got to be the other factor. So I believe that this is the answer. Notice this problem is a lot harder when it's not a 1x squared. If it's something other than a 1, then you get quite a bit of work to do. And again, this is the AC method. All right, I don't know if it's right yet, so I got to check it. So down here, let's see if I can squeeze in a check. So I think that if I take 3x minus 4 and multiply it by x minus 2, then I'm going to get that original thing. So we're going to ignore that original thing for a minute and just keep our eyes focused down here at the bottom. 3x times x, yep, that is 3x squared. And so I just did that. 3x times minus 2, always be sign conscious, is minus 6x. Done with the 3x. Now the 4, it's a minus 4. Minus 4 times x is minus 4x. And minus 4 times minus 2 is a plus 8. Okay, always whenever you have signs, rethink. Is that really right? Negative times a negative is a positive. Yep. Happen to be like terms in the middle. Those guys add up to negative 10x. Plus 8 is hanging out on the right. 3x squared is hanging out on the left. And that is a match. Whew. Check. We got it right. Double circle. Exclamation point. Boom, done. Whew, that was a lot of work. Okay, so I'm expecting to see work just like this on your quiz. If you showed less work than this, then we might have a problem. I'll get back to you and tell you once I grade it. All right, next one. Now here I have no middle term, which is interesting. So I could, if I wanted to, think about this as x squared minus no x's, or sorry, plus no x's, plus or minus 0, who cares? So there's no x's, and then I have the minus 9. Okay, so my factoring method is still going to work here, whether I write it this way or not. What's important to me is that negative 9, and negative 9 factors as 3 times 3. Do you remember what the negative means? Yep, negative means that you're going to subtract the factors. So that's cool because 3 minus 3 happens to be 0, and there are no x's in the middle. So I believe this factors as x plus 3 times x minus 3. Another way to solve this problem besides our factor by guessing or AC method is to kind of memorize a formula. And so in one of the sections, they go over special products. And those are also listed on my general factoring strategy. And so they are the difference of two squares factors. The sum of two squares does not. We call it prime. The difference of two cubes factors, and the sum of two cubes factors. And I do expect you to have these formulas here memorized for the test. So write those down repeatedly to help commit them to memory. All right, so I think I have an answer, but I'm not sure because I haven't checked yet. So writing it down again for a check. X plus 3 times x minus 3. And again, the more you write down, the better, and it takes practice to write down sufficient work. So practice on your homework. X times x is x squared. X times minus 3 is minus 3x. Okay, this x has been distributed to everything over there, so now I move on to the 3. Plus 3 times x is plus 3 times x. And plus 3 times minus 3 is minus 9. Like terms happen to be in the middle. Negative 3 and a positive 3 is a 0x. So the answer does seem to be x squared minus 9. The check seems to be matching the original. And so, yep, I do have a factored form for that. Okay? Write down some work. Write down a check. I expect to see that anytime you take a test or a quiz, and I do expect you to do that on the homework too. All right, that's it for now. Go forth and do good math. Have a great day. Bye-bye.